adding and subtracting rational expressions, and this video is where the fractions already have a common denominator. So again, a rational expression is a fraction where both the numerator and denominator are polynomial expressions. When you have a rational expression, you always need to remember that there are restrictions if there are any x's, any variables in the denominator or the bottom. All right. So for more information on these restrictions, watch my video, Rational Expressions Restrictions. All right, a special note here, if you are given a rational expression, you must always find the restrictions before you simplify, okay? And when simplify, I mean before you add, before you subtract, before you multiply, divide. We're not doing that in this video, but before you do any of those things, find the restrictions. All right, and for the purposes of this video, I'm not going to find the restrictions, but understand that they exist. All right, I will focus only on the simplification of the rational expressions here, adding and subtracting them, and then factoring and dividing out common factors. And please understand that they exist on every one of these expressions that we will simplify. All right, when you add or subtract rational expressions, you must have a common denominator. That is super duper important, a common denominator. You cannot add two fractions that don't have a similar or common or same denominator. Only when all rational expressions have a common denominator can you add or subtract them. All right? Once you have a common denominator, you combine the numerators and keep the common denominator. The denominator doesn't change. So while you may add the numerators or subtract the numerators, the bottom, the denominator, doesn't change. Don't add or subtract that number. Okay? The whole reason, the whole purpose you get a common denominator is to keep it over that same common denominator. All right? When you add, simply keep the same signs of all the terms in the second numerator and combine like terms. So many times people get caught up on the fact that add, a plus sign means add. Actually, a plus sign means don't change the signs. If you distribute a positive sign to everything in the second fraction in the top, it just doesn't change the signs. So if there's already a negative there, it stays negative because you're doing a positive times a negative. All right, so leave the signs the same and combine like terms if you are adding. If you are subtracting, be sure to distribute the negative. Thus, you change all the signs in the terms of the second numerator. So if the second numerator has 3 terms in it and you're subtracting, you actually have to take that negative and distribute it to all 3. And the first sign is not what's in front of the fraction, it's what's up top. If there's nothing in front of it, it's understood to be a positive. So that's very important when you are doing these. And then you simply combine like terms. A minus sign does not mean subtract. It means change the signs and then combine like terms with the rules you know. After you have simplified the numerators, okay, you move on to the final 2 steps, which are to factor, the combined numerator and common denominator. Okay, so you have the numerator that you've now combined the terms with and the common denominator, and divide out common factors. And then this is a preference that I have. I prefer to leave both the numerator and denominator factored, as this says to anyone that looks at it, I know nothing else divides out. All right, and so I ask my students to do the same on tests and assignments and that kind of thing. Show it to me factored so that I know that you know that nothing else divides out. So without further ado, let's work some of these. 5x over 19 plus 7x over 19. Here I have an LCD. My LCD is what? It's 19. Okay? Right? Same denominator on both fractions. Don't have to worry about, how do I get it or whatever. It's already the same denominator. So, and actually I said every problem, this particular problem doesn't have any x's here in the denominator, so it actually does not have restrictions. I'm not going to find them, but we can recognize, hey, this one doesn't have restrictions for that purpose. So this is going to end up being 5x plus 7x, okay, over 19. And again, the plus sign says take these two things with the signs they have. Well, there's nothing in front of either one of them, so they're both understood to be positive. So that's why I put that plus in front of the 7x. Not because this plus is here, but because I'm not changing this sign. All right? So then 5x plus 7x, when we add those together, that is 12x over 19. Now, don't get careless on me and try to say 12x squared. If you add $5 and $7, no one has ever told me that's $12 squared. What is $1 squared anyway? Right? So when you add like terms, you get a like term. When I add 5x and 7x, I get 12x. So 12x over 19. And then I would look at this because 12x is one term, I can look at 12 and 19. Do they have anything in common? Not 9, but 19. All right? So the 12 and the 19 don't have anything in common, so I cannot do anything else with that as far as dividing out a common factor. So my final answer here is 12x over 19. And I put these boxes here for us to place our final answers in, much like my students would do on a test. The next one to the right of it, 17 over 9x minus 2 over 9x. Now this one, because it has x down here in the denominator, would have a restriction. All right? Anytime you put x in the bottom or a variable in the bottom, you have a restriction. So here, what is my LCD? My LCD is 9x. So then I'm going to have everything over 9x, and this time I'm subtracting 17 and 2. But look, this minus sign says change the sign of that 2. Now, I know this is a simple case because it's one number. So, no, it means minus 2. The reason it means minus 2 is because that minus sign says change the signs of everything in the next fraction. And everything there is a 2. So, change it from positive 2 to negative 2. All right? So, 17 minus 2 is 15 over 9x. But wait a minute. Because this is one term down here, does 15 and 9 have anything in common? Well, actually, look for that in brown here. Right. So then here, what do they have in common? That's right, 3. So how many times will 3 go into 15? 5 times, and 3 goes into 9 3 times. So this becomes 5 over 3x. And that is now our final answer here. So you don't want to leave 15 over 9x. You want to simplify it all the way. You want to divide out that common factor there and say it's 5 over 3x. That's the simplest form that you can give that answer in. All right? And I want to say something as we write these fractions here. I'm a big stickler on this. Don't write slanted fractions. On either one of these, probably you're okay. 5 over 3x has the potential to not look very good and possibly be misinterpreted. There's nothing you can misinterpret about the way I write my fractions. Now my handwriting's bad, I know that. But you don't wonder, is 12x in the top or the bottom of my fraction? Is 3x in the bottom? Is it just 3 in the bottom and x is out to the side? You don't wonder that when I write a fraction. All my fractions are horizontal, and everything in the top, the numerator is written up top. Everything in the bottom's in the bottom, and the fraction line extends fully. So I would suggest that you get in that habit. Okay, that's some details that would help you be better at math, and the rules wouldn't seem like they change every 5 minutes. All right? But that would be carelessness there of not paying attention to the details. So I would encourage you to write only horizontal fraction lines and make sure they extend fully, and everything in the top's in the top and bottom in the bottom, and then there's no ambiguity whatsoever. All right, so the next one, what is my LCD on the next one here? My LCD is x minus 4, right? It's already the same thing, which is wonderful, all right, which is so wonderful. So that means I'm going to have this whole thing over that same thing, x minus 4, and a plus sign means don't change anything. So the 2 and the 10 are both positive, so keep them that way. All right? The 2 wouldn't change anyway unless there was something in front of it, and here we're not doing that. So then we have 2 plus 10, which is 12 over x minus 4. Now, we have to be careful here. X minus 4 is how many terms in the denominator? It's 2. It's 2. This is the first term and this is the second term. When you have 2 terms, you can never divide out. Like, you can't take these 2 things and divide them out because you have 2 terms down here. If you have a string of terms, meaning more than one term, 2 terms, 3 terms, 4 terms or more, okay? 2 or more terms, you can never take one of those terms and divide it out with something in the other part of the fraction. Whether it's in the numerator or denominator, you can't divide it out with something else. It can never happen. When you have multiple terms involved, you have to have that entire factor, like x minus 4 over x minus 4, for it to divide out. So this is the final answer. So 12 over x minus 4. And hopefully you'll see that as we go through this, that you can't do those kinds of things, and you'll begin to understand if it's not quite clear yet. So the next one, the LCD is y plus 7. So I have y. And then look, this plus sign says don't change any of those signs. So it's going to be a positive 9y, because scribble this out. That's what this is. That's positive. There's nothing in front of it. And then minus 3 all over the LCD. That's why you get it over an LCD right there. All right. And then I need to simplify the numerator. There was nothing to simplify on the last one, but here I have like terms. Don't go crazy on me. Just go combine your like terms. What is y plus 9y? That's 10 y's, right? Minus 3 over y plus 7. And that I extended that a little too far. We'll fix it there. All right. So 10y minus 3, y plus 7. And again, there's 2 terms and 2 terms. So unless you can factor those to be identical, you cannot divide anything out. And 10y minus 3 up in the numerator does not factor. And y plus 7 in the denominator does not factor. So that is your final answer here. All right, so 10y plus 3, I'm sorry, not plus 3, minus 3 over y plus 7. All right, so let's see what we have over here on the next page. We have w squared minus 2w over w squared plus 3w and w squared plus w over w squared plus 3w. So we have an addition. That's the first thing we identify. We're adding these things. All right, and I should have said that on the other ones. I should have said, what are we doing from the beginning? We're adding, we're subtracting, we're adding, right? That's what we're doing. We are identifying what it is we are doing from the beginning. So here we're adding, and if I'm adding or subtracting, I must have an LCD. And in this case, w squared plus 3w is my LCD. Now, if you say, Mr. Guest, I know I'm going to factor this in the end anyway because I want to see what divides out, you can go ahead and factor that now if you want to. All right, but if you don't now, that's fine. So let's just come over here and say this is w squared plus 3w, and then w squared minus 2w, and then we have a w squared and a w. And the reason I write it this way is I've got to figure out what goes here and here for signs. Remember, if there's a plus sign, I don't change those signs. And if there's a minus sign, then I do change those signs, right? So this is a plus sign, so I don't change them. So what kind of w squared do I have right here? It's what? It's plus, because there's nothing written in front of it. It's understood. It's the first term there. And then this w is also plus, so we don't change the sign because of this plus. That means don't change the sign. So then we have w squared, so I'm going to put like two little curves over these squareds because they go together, and then one over this. And notice I tried to get this minus sign in there with it, right? This minus sign goes with that 2w, right? So this is going to end up being 2w squared, and then minus 2w plus w is minus 1w over w squared plus 3w. Now I have simplified both, or the numerator, I've simplified it. The denominator didn't need any work. It was already common. So I've simplified the numerator. Now my final two steps are always factor and divide out. I just couldn't factor anything on the page before, but here I can actually factor this. So if I factor this numerator up here, it's got a GCF of w, right? They have a w in common, so let's take w out. And we have 2w minus 1. And then in the denominator, they also have a what? A w in common, so let's take that w out. And we have w plus 3. Now, even though this has two terms in it, this entire thing is one term because it is completely factored. That's why you factor, because you are getting the numerator and denominator into one term. Even though some of the factors themselves may have more than one term, you have everything multiplied together. So then once that happens, then I can come back and go, hey, guess what? These w's divide out, but there's this 2w minus 1, there's not one of those in the denominator, so it stays. So this is going to be 2w minus 1 over what am I left with in the denominator? W plus 3. And you cannot cross anything out there. Those w's cannot cross out because, again, if you have one term, you can't cross out one term. That's a no-no. You have one term out of a string of terms. You can never cross something out from that. All right, if you have more than one term, and what separates terms? Pluses and minuses, okay? Pluses and minuses separate terms. So look at the next one. This one is a subtraction, which means I'm going to change all these signs over here, okay? That's all it means. It doesn't necessarily mean subtract. It means change the signs and then combine like terms the way you know how. All right, so my LCD here is x squared plus x minus 2. So let's come over here and say, okay, I'm going to come down just to give myself a little more room here, equals. This is x squared plus x minus 2. And we have x squared minus 2. The first fraction never changes unless there's nothing in front of it here to change it. Okay? And then here, we take this negative and distribute it. So we have an x squared and a 2x. All right, notice I extended my fraction line out right there just to make sure it was long enough. All right, so then here, the x squared here is positive. So I change it to what? Negative. And this is negative, so I change it to what? Positive. And now I'm ready to put these things together. I have two lines over my x squareds. All right. So x squared minus x squared, that actually does what? That actually cancels, doesn't it? And that leaves me with, and I'm going to write this in descending order. You don't have to do this way, but I'm going to write 2x minus 2, right? I just wrote this term first, and then wrote this term over here second. Okay? And that's over x squared plus x minus 2. All right, well, can I factor this? Let's look here. I'll just keep working across here. So in the numerator, I have what? What's in common up here? A 2. Always look for that common factor first, and I'm left with x minus 1. Do I have anything in common down here? Nope, but it's 1, 2, 3 terms, and if it's 3 terms and this number out front's a 1 with no GCF, I call that list method, okay? Now, you may can factor it some other way. That's okay as long as you can factor it. But if you can't, watch my list method video because it will help you and give you rules that will always, 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 always work. All right, so here I look for the factors of 2 that subtract to give me 1. I don't worry about the plus or minus right now. So the only factors of 2 are 1 and 2, and guess what? They do subtract to give you 1. So 1 and 2. And then this says different signs, so the bigger number gets the first sign. The bigger number, 2, gets a plus, and 1 gets a minus because they're different. The only way to get a negative 2 there is if the signs are different. That's how I know they're different. All right. So then I look at this and go, okay, 2 stays because, look, this is 1 term and this is 2 terms. You cannot cross that out. That is no, 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 no. You can't do that, okay? But you look at this, x minus 1 is 2 terms, and this is exactly x minus 1. If that was 2x minus 1, you couldn't do it, or 5x minus 1, but it's x minus 1 in parentheses with another x minus 1 in parentheses. So this is good. You can actually get rid of those, okay? They divide out, and that gives us 2 over x plus 2. And again, 2 terms here. You cannot cross those out. No, 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 no. All right? So 2 over x plus 2. So 2 over x plus 2. If you have 2 terms, you cannot cross one single term out of those 2 terms. Okay? And you can't break that up in the denominator. If that was x plus 2 on top, you could break that up, but you cannot break up the other because it's a common denominator. You can't break your common denominator up when it's more than 1 term. And then here, this one, the LCD is x squared plus x minus 12. So we have x squared plus x minus 12. That's a pretty ugly x. I know my handwriting's bad. You don't have to write it in and tell me. X squared plus 5x. And then we have x squared and 20. Okay? Again, the reason I do that is I have to decide, do I change my signs or keep them the same? Well, I should have identified it before I started. This is a subtraction, which means change all these signs. It means change all those signs. So if I go to change those signs, we have what? We have an x squared here is positive, so it changes to what? Negative. And this 20 is negative, so it changes to what? Positive. And now, again, I combine my like terms here. X squared minus x squared, those cancel because x squared minus x squared, right? And that leaves me with 5x plus 20 over my LCD, right? So I can't do anything else. I've simplified my numerator. You always want to make sure you simplify your numerator first. And let me say this. On ones that already have a common denominator, that should happen relatively quickly. When we have to find the common denominator, we may do 7, 8, 9 steps right there. All right? So, and I have a video for adding, subtracting rational expressions without a common denominator. All right? So it becomes a little more complicated at that point because we have to make the denominators the same. All right, so here, we're going to come down here and say, okay, this is going to be, let's see, what do these have in common? A 5, right? They have a 5. So let's take that 5 out and say x plus 4. All right, and down here, hopefully in the denominator, you've already realized this is list method. There's nothing in common, 3 terms, and there's a 1 right here, right? So I need the factors of 12, 1 and 12, 2 and 6, or 3 and 4. The factors of 12 that subtract to give me 1. What are they? 3 and 4, right? So let's come down here and put x and 3 and x and 4. And the signs are different, and the bigger number gets a plus. So which one's bigger here? 4 is bigger than 3, right? So the 4 gets a plus, and since they're different, the 3 gets a minus. Again, if you have trouble with that, list method video, right? And finally, can I divide anything out? Well, the 5 doesn't have anything in common with it. The x plus 4, and I'm always going to work my way across. This factor, and if I have another factor, I'm going to work my way across. All right? So x plus 4 and x plus 4 divides out because those are identical x plus 4s. Okay? And so we end up with 5 over x minus 3, and there's nothing else I can do there. So 5 over x minus 3. Hope this helped out. Good luck with your algebra.